I've just received a strange folder. 3 files. No explanation, just one message. Find the person behind the case. So naturally, I opened the first file, and that's when things got interesting. Because this file contains clues. The second contains a list of suspects. And the third, we don't even know what's inside. So today we are going to investigate these files using Python. And while solving the case, you are going to learn file handling from beginning to end. We'll cover text files, file modes, reading and writing, file pointers, CSV files, binary files, pickle, exception handling, and finally we'll build a small detective style record system. Let's open the first file. Before we open anything, there's one question. Why can't we simply store everything in variables? These are variables. They're excellent while our program is running. But now let's imagine our program ends. Everything is fine, but once the program terminates, those variables are not automatically available the next time we run the program. That's because variables are used for temporary working data in memory. A detective agency can't store thousands of case records only in variables. We need persistent storage. And that's exactly what file handling gives us. Instead of losing our information when the program ends, we can store it in a file and retrieve it later. Our first piece of evidence is clues.txt. That's a text file. Let's open it. There are 3 important things here. Open is Python's built-in function for opening a file. Clues.txt is the file name, and R is the mode. R means read. The result is stored in F, but F doesn't contain the text itself. It is a file object, our connection to the file. Read function reads the contents of the file. Let's see what our detective file contains. Okay, that's our first clue. But notice something, we are not finished with the file yet. Close closes the file. Files use system resources, so when we are finished, we should close them. But what if I don't want to just read the file? What if I want to create it, replace its contents, or add something without deleting what's already there? That's where file modes become important. In this statement, R means read. The file must already exist. The next mode is write mode. W means write. If the file doesn't exist, Python creates it. But here's the dangerous part. If it already exists, its previous contents are truncated, essentially cleared, when opened in write mode. That's why W can be dangerous if you don't intend to replace the existing data. The next mode is append. A means append. Instead of replacing the existing content, new data is written at the end. The next one is exclusive creation. X means create a new file exclusively. If the file already exists, Python raises an exception. So this is useful when we specifically want to make sure we are creating a brand new file. The next mode is read plus write. R plus allows both reading and writing. Similarly, Python has W plus, A plus, but remember, W plus still has the truncation behavior of W. A plus writes at the end. Next are binary modes. There is one more letter, B. It means binary. RB is for read binary, WB is write binary, and AB append binary. We'll need these when we investigate our final piece of evidence. Now let's investigate this file properly. Python gives us several ways to read text. The first function is read. Read with no argument reads all remaining content. Read can also accept a number. That tells Python to read up to that many characters from the current position in a text file. Next is readline. It reads one line. Let's read another. The second call continues from the current file position. The next function is readlines. Readlines reads the remaining lines and returns them as a list. Notice the \n. That's the new line character. Now we have discovered something important. When we read one line, Python doesn't magically forget where it was. The file has a current position. Think of it like a detective's bookmark. Tell function. Tell function tells us the current position of the file pointer. After reading a line, the pointer has moved. So tell can show us the new position. Next is seek function. Seek function changes the position, and 0 means go back to the beginning. Seek has moved the file pointer to the beginning of the file. And look, we are reading the first clue again. We have found enough evidence to create our own detective report. Let's write our own clue with the help of write function. Write function writes a string to the file. And notice that I explicitly used \n because write doesn't automatically move to the next line. Now we have 2 lines. Now suppose I already have multiple strings. We can use writelines. Writelines doesn't automatically insert new lines. That's why I included \n inside each string. You may have noticed that I'm using with open instead of manually opening and closing the file. Why? The with open statement automatically closes the file when the block ends. That makes our code safer and cleaner. For most modern Python programs, this is the style I recommend. Next are file properties. Name gives us the file name. More tells us how the file was opened. Closed tell us whether the file is closed. Inside this block, it will normally be false. Once the with block finishes, the file is automatically closed. One more thing before we move on. Text files use an encoding. We can explicitly specify UTF-8. Encoding UTF-8 tells Python how the bytes in the text file should be interpreted as characters. You'll often see this in professional Python code when working with text. We have been given another file name. Let's open it. And there it is. Our program crashes. But a good detective program shouldn't simply collapse because a file is missing. Try means try executing this code because something might go wrong. If the file exists, we'll read it. If the specific problem is FileNotFoundError, we handle it gracefully. Now we are combining 2 good practices, exception handling and automatic file closing. The text file gave us clues, but now we have found something much more useful, a suspect database. And it looks like this. This is a CSV file. CSV stands for comma separated values. It's especially useful for tabular data. CSV is a module from Python's standard library. csv.reader creates an object that lets us read the CSV row by row. Now let's investigate each row. Every row comes back as a list. But here is an important observation. 87 came back as a string 87. If we need to perform numerical calculations, we may convert it. Next reader moves past the first row, which is our header. So the header is skipped. But there is another way I really like for readable code. Now each row behaves like a dictionary using the header names. Now instead of remembering column positions, we can say row of name. That's much easier to read. We have discovered another suspect. Let's add a new CSV file. csv.writer creates the writer object. writerow writes one row. Now we have multiple rows. Writerows writes multiple rows. Now let's use dictionaries. Field names tells the writer what our column names are. Writeheader writes those column names as the first row. And now one complete dictionary has become one CSV row. We have solved the text clues. We have investigated the CSV suspect list. But now we have our strangest file, evidence.dat. If I open it as normal text, I may get meaningless characters. Why? Because this is binary data. RB means read binary. The B tells Python we are dealing with bytes. We are only displaying the first 20 bytes. Next is writing into the binary files. WB means write binary. We are taking the bytes we read and writing them into another binary file. That's essentially how we can copy binary data. But there's something even more interesting. What if our evidence isn't just random bytes? What if we want to save an entire Python's object? This is a Python dictionary. Normally, if we close the program, this object disappears from memory. But we can serialize it. Pickle is Python's module for serializing Python objects. Look carefully. We are using WB. Why? Because Pickle stores the serialized representation as binary data. And pickle.dump means serialize this object and write it to the file. Load does the opposite. It reads the serialized data and reconstructs the Python object. We didn't manually rebuild the dictionary. Pickle reconstructed it for us. These two words are worth remembering. Serialization, converting an object into a storable representation. Deserialization, reconstructing the object from that stored representation. Our detective agency has more than one suspect, so let's store a complete list. One Python list containing several dictionaries. We can serialize the entire list with one dump. And retrieve the entire list with one load. But there is another interesting technique. We can append another serialized object. AB means append binary. Now we have serialized another object after the first one. Next is reading until end of file. We keep loading objects. When there are no more serialized objects, pickle.load reaches the end of the file. That's when EOFError can occur. We catch it to stop the loop. Here is one important real-world warning. Don't blindly unpickle files received from untrusted sources. Pickle is designed for Python object serialization, not for safely processing arbitrary, untrusted data. For our own trusted data, it's extremely useful for learning this concept. Now let's put everything we have learned into one practical system. Our detective agency needs to add a suspect, display suspects, search for a suspect, update a suspect, save the records. Let's build it. Let's first load existing records. We try to load our existing database. If this is the first time we are running the program, the file may not exist. Instead of crashing, we'll start with an empty list. Let's add a record. We create a new dictionary representing one suspect. Then we add it to our list. And now we save the updated list back to the binary file. Now the detective wants to find suspect number 102. We ask the user for an ID and convert it to an integer. We'll search through every dictionary in the list. Here we compare the current suspect's ID with the ID entered by the user. If we find a match, we display it and stop searching. If the loop finishes without finding a match, we tell the detective that the record doesn't exist. Now imagine the score for suspect 102 was entered incorrectly. We need to update it. Then we collect the ID and the new value from the user. We search through the records again. Once we find the matching dictionary, we change its score. And finally, we save the modified list back into the file. Otherwise, the change would exist only in memory and disappear when the program ends. And that's it. We started with one mysterious folder, and along the way, we learned almost everything you need to know about Python file handling. We learned how to open files, read files, write and append data, move through a file using seek, check our position using del, handle missing files, work with CSV data, work with binary data, serialize Python objects with Pickle, retrieve them using load, search records, update records, and build persistent data storage. And that's how we solved the digital detective mystery. But there is one bigger lesson here. A Python program can process data, but file handling allows that data to survive the program. And that's why file handling is such an important Python concept. If you enjoyed learning this through a real investigation rather than simply memorizing functions, subscribe. The mystery is solved, but the journey continues. Keep coding, keep experimenting, and I'll see you in the next one. Case closed.